Welcome to the DIY Honda Garage channel. DTC P16E3 refers to a PGM-FI programmed fuel injection issue characterized as a battery sensor LIN local interconnect network communication error in the 2022 Honda Civic. This error occurs when the powertrain control module, PCM, is unable to receive signals from the 12-volt battery sensor through the LIN communication system. The 12-volt battery sensor plays a critical role in monitoring the battery's voltage and providing this vital information to the PCM. The sensor is typically located near the battery itself, connected via wiring to the PCM. Proper functionality of the sensor ensures that the vehicle's electrical systems are operating correctly. If the PCM detects an anomaly in receiving data from the sensor, it logs the P16E3 fault code, leading to potential operational issues if not addressed. Therefore, accurate diagnosis following the indicated procedures is essential for proper repair and vehicle performance. The primary component involved in DTC P16E3 is the 12-volt battery sensor. This sensor has the important function of monitoring the voltage levels of the vehicle's battery, which is essential for various electronic functions in the Honda Civic. It sends this data to the PCM via a LIN communication network. The sensor's accurate readings are crucial for ensuring that the vehicle performs optimally and that the battery does not discharge or overcharge. The sensor is typically mounted near the battery itself for easy access and to ensure accurate readings of the battery's voltage levels. If the PCM does not receive these signals due to a fault in communication, it triggers the P16E3 code, indicating that there is a communication error that needs to be resolved for the vehicle to operate correctly. Several factors can lead to the triggering of DTC P16E3. One common issue is loose terminals at the 12-volt battery sensor, which can disrupt the communication between the sensor and the PCM. If the sensor itself is faulty or damaged, it will not provide accurate data, which can also cause this error code. Additionally, issues in the LIN communication circuit, which is responsible for transmitting data between the battery sensor and the PCM, may result in the PCM being unable to receive the required signals. Lastly, a malfunctioning PCM can also lead to this error if it fails to accurately process or recognize the information being sent from the sensor. Each of these potential causes requires careful inspection during the troubleshooting process to ensure a successful resolution. The presence of DTC P16E3 can lead to several noticeable symptoms in the Honda Civic. One of the most common indications is the illumination of the check engine light, CEL, alerting the driver to an underlying issue that requires attention. Additionally, there may be noticeable electrical system malfunctions, such as issues with starting or operating electrical components. The car may exhibit poor performance, such as hesitation during acceleration or unusual idling conditions, as the PCM relies on accurate data from the battery sensor to make fuel delivery and ignition timing adjustments. If left unaddressed, these symptoms can lead to more serious vehicle performance issues. Drivers should be aware of these signs and seek diagnostics to rectify the situation and prevent further complications. The first step in troubleshooting DTC P16E3 involves checking the 12-volt battery sensor itself. Start by inspecting the sensor and its connections, specifically looking for any loose terminals that may disrupt the communication between the sensor and the PCM. Loose or corroded connections can lead to intermittent signals, which the PCM interprets as an error. Ensure that all wiring connected to the sensor is secure and free from wear or damage. Proper functioning of the sensor is crucial for the vehicle's electronic systems, and establishing solid connections can often resolve the issue. If connections appear normal, further inspection of the wiring for any signs of damage should be conducted, potentially pointing to issues further along the circuit. The second troubleshooting step focuses on inspecting the LIN, local interconnect network, circuit connected to the battery sensor. Begin this process by testing the components associated with this communication line to verify if they are functioning correctly. It is essential to check for any shorts or opens in the LIN circuit, as these can disrupt the communications necessary for the battery sensor to relay information to the PCM. A visual inspection should be complemented by using diagnostic tools to measure continuity and potential voltage issues. Any abnormalities found in the LIN circuit can lead to the P16E3 error and should be corrected to ensure proper communication within the vehicle's electrical system. Continuing the troubleshooting process, the third step involves inspecting the external circuit linked to the battery sensor. This includes a thorough check of all connections associated with the 12-volt battery sensor. Pay particular attention to the integrity of the wiring, ensuring that there are no visible damages such as fraying, corrosion, or breaks that may impede the signal flow. A successful inspection should determine if the external circuit is intact and free of fault, as any deficiencies can contribute directly to the communication issues indicated by DTC P16E3. It is vital to ensure that everything is in proper condition to maintain vehicle functionality and reliability. The final step in the troubleshooting process addresses the PCM, or Powertrain Control Module. If previous inspections confirmed that all electrical components and connections are functioning properly, it becomes necessary to evaluate the PCM itself. This involves testing for any communication faults that may stem from the PCM end. Using specialized diagnostic equipment, technicians can measure the PCM's responsiveness and functionality regarding the signals from the battery sensor. If the PCM is determined to have failure or fault codes beyond what has been detected, replacement or reprogramming may be necessary. Addressing PCM issues is critical to restoring the vehicle's performance and ensuring seamless communication across its electrical systems. After completing the troubleshooting and necessary repairs associated with DTC P16E3, it's essential to perform a final verification of repairs. Begin by clearing the DTC from the PCM and conducting a test drive to confirm that the issue has been resolved. During the test drive, monitor the vehicle's performance and observe whether any warning lights reappear on the dash. Additionally, upon completing the drive, conduct a scan again to check for any recurring codes. If the P16E3 code does not return and the vehicle operates normally, it indicates that the repairs were successful. This verification step ensures that the resolution of the issue was effective and maintains the reliability of the vehicle's electrical and engine systems. Preventive maintenance plays a crucial role in avoiding issues associated with DTC P16E3 and ensuring the long-term reliability of the Honda Civic. Regularly checking the battery and its sensor can help identify potential issues before they lead to communication failures. It's important to maintain clean and secure connections for the battery sensor to mitigate the risk of poor signaling. Situational awareness of proper wiring integrity can assist in reducing the potential for faults. Additionally, keeping the vehicle's software updated ensures that any known issues are patched and features operate optimally. By implementing these routine checks and maintenance, drivers can largely negate the chances of experiencing P16E3 errors in the future. In summary, DTC P16E3 signifies a communication error stemming from the 12-volt battery sensor in the Honda Civic 2022 model and beyond. Understanding the role of the battery sensor and the importance of the LIN communication network is crucial for effective troubleshooting and repair. A systematic approach to inspecting the various components including the wiring and the PCM, is necessary to localize the issue accurately. Ultimately, timely diagnosis and proper maintenance are key in preventing future occurrences of this fault code. Engaging in preventive measures, as discussed, can lead to enhanced vehicle reliability and performance, ensuring optimal operation for all electronic systems within the Honda Civic. Please like and subscribe to the channel. See you next time.